All right, folks, welcome to the Unit 7 test review, all right? So up here at the top, you might have noticed it says Unit 7 mid-quiz. Well, it's not the mid-quiz. This is a Unit 7 test. So do not be alarmed by that. If you have not completed the practice test yet, or you haven't gone through it on your own and written down your own answers, stop the video and go ahead and do that first, okay? It's not gonna help you at all in studying if you just listen to me give you the answers here, okay? All right, so let's start off with number 1. What is the value of 5 to the 4th power? All right, so you could type in your calculator 5 to the 4th power, or you could just write it out as well. 5 times 5 times 5 times 5. So we're multiplying 5 by itself 4 times. Well, 5 times 5 is 25, times 5 again is 125, times 5 again equals 625. So if you got 625 for your answer, give yourself a +1. Actually, we're not grading this. This is a practice test. Never mind. Whew, old habits die hard. Anyway, so if you got 625, good work. All right, so number 2, how many times bigger is 4 to the 17th compared to 4 to the 14th power? All right, so let's see this. So 4 to the 17th and 4 to the 14th. Let's write this one out. So 4 to the 14th power. If we're going to get 4 to the 17th, well, 4 to the 17th is the same as 4 to the 14th, and then you just multiply 4 by that 3 more times, right? Because 14 plus 1, 2, 3 more 4s is equal to 17. Okay, now if you think about this, right? 4 to the 17th has 3 more 4s being multiplied together in it, okay? So 4 times 4 is 16. Times 4 again is 64. So 4 to the 17th is the same as 4 to the 14th times 64, which means that 4 to the 17th is 64 times bigger, okay? So, if you got 64 times bigger, congratulations. All right, let's go on to number 3. So rewrite 10 to the 15th times 10 to the 24th using a single exponent. All right, so we've got the same base. All we have to do is use the power rule and add those exponents up. So 15 plus 24 equals 39. So you wrote 10 to the 39th, you would have gotten that problem right. Way to go. All right, let's look at number 4. So it says, here are some equivalent ways of writing 10 to the 4th power. We've got 10 to the 3rd times 10, or 10 to the 2nd to the 2nd again. Write 3 different expressions that have the same value as 10 to the 8th. So we're not writing 3 more that have the same value as 10 to the 4th. That was just an example. We want to have the same value as 10 to the 8th. So let's do this. We can write one, let's see, 10 to the 6th power times, we'll just use the product rule first, right? So what plus 6 equals 8? You're right, 2. So 10 to the 6th times 10 to the 2nd would also equal 10 to the 8th. If you wanted to use the quotient rule, 10 to the 10th, 10 minus what equals 8? 10 minus 2. So 10 to the 10th divided by 10 to the 2nd would also equal 10 to the 8th. Now, if you wanted to use the power rule, let's say we had 10 to the 2nd to the 4th power. 2 times 4 equals 8. So that would work as well, okay? If you got a different answer and you're not sure if it will be correct, if you type your answer into the calculator and you get 100 million or 1 with 8 zeros behind it, oh, sorry, that's 10 million. Ooh, jeez. Oh, no, 100, 200. I just did. Oh yeah, no, that's 100 million. There you go. So if you get 100 million or a 1 with 8 zeros behind it, you are set. All right. Your answer would be correct as well. So let's look at number 5. Why is 10 to the 16th divided by 10 to the 9th equal to 10 to the 7th? Explain or show your thinking. Well, first of all, we have to use the quotient rule. That would be the first part of your explanation, would be explaining the rule or the correct rule to use. So in the quotient rule, we subtract the exponent in the numerator, in the quotient rule, we subtract the exponent in the numerator from the exponent in the denominator. So we have 10 to the 16th minus 9th equals 10 to the 7th, because 16 minus 9 equals 7. All right? So there's your explanation. We use the quotient rule. We have to subtract the exponent in the numerator from the exponent in the exponent in the denominator from the exponent in the numerator. All right, so number 6 says mark each of the following equations as true or false. Explain your reasoning. Okay, so, this first one's perfect. So we have to use the power rule here. All right, so 2 times negative 3 is going to be 10 to the negative 6. And what's negative 2 times positive 3? Well, that is also negative 6. So this one is true. Okay. Now, B says 10 to the 3rd divided by 10 to the 14th. So we have to subtract here. We're using the quotient rule. 10 to the 3rd minus 14 does in fact equal negative 11, right? The number in the denominator is larger. So that means we're going to have a negative exponent, which is fine. That means this one's true. Awesome. All right, and then this last one, 10 to the negative 5th, that's going to be the same as 1 over 10 to the 5th if we use the negative exponent rule. It's going to be a very small fraction. It's equal to, so here we've got negative 10 to the 5th, which is the same as negative 10 times negative 10 times negative 10. Okay, you get the idea. It's a very large negative number. So this one is false. They're not going to be the same thing. All right, awesome. So number 7, Andre was trying to write 7 to the 4th divided by 7 to the negative 3rd with a single exponent and wrote this. All right, so he did 7 to the 4th over 7 to the negative 3rd. He used the quotient rule and subtracted the 2. He got 7 to the 1st. But wait, this exponent's negative. He subtracted a positive number from 4. So really what he should have done is done 7 to the 4 minus negative 3. If he subtracted that negative number, he would have gotten 7 to the 7th, right? Because this is the same as adding, right? So that's what he did wrong there, okay? There you are. So if you had that explanation that he forgot to include the negative from this exponent in this part of the problem, that would work. Now let's look at what Diego did. So Diego was trying to write 2 to the 3rd times 2 to the 2nd and wrote this. Oh, Diego. All right, so he used the power rule. He multiplied exponents. Now the only thing is, the problem here is we use the power rule when we have one base and parentheses, right? Ooh, that one's wrong. Anyway, let's try this again. 2 to the 3rd to the 2nd. Now here we would multiply 2 times 3 and get 2 to the 6th. But there's no parentheses. There's 2 bases. They are the same. So in fact, we just add the exponent. And we get 2 to the 6th. Okay? And there you go. So what did he do wrong here? He used the power rule when he should have used the product rule. That's what he did wrong. All right, now let's look at number 9. So number 9 says rewrite each expression using a single positive exponent. All right, so the exponent has to be single and positive. Great. So let's do this one. So here we're using the quotient rule. We have to subtract the denominator from the numerator. So we have 9 to the 2nd minus 7th, which, what's 2 minus 7? Well, it's going to be a negative number, right? It's going to be to the negative 5th. So we're done here. It's a single exponent, but it's not positive. Oh, man, what are we going to do to make this positive? Well, we'll use the negative exponent rule. When we have a negative attitude, we send them to the basement, right? And then they get more positive. So it doesn't say anything about your answer being a fraction, so this is a correct answer here. This is the correct answer, 1 over 9 to the 5th. Now for B, we've got 14 to the negative 5th power times 14 to the 16th power. Okay, so we're using the product rule here. We're adding the 2 exponents, and we are going to get, well, negative 5 plus 16 equals negative 11. There you go. You now have your answer. Ka-ching. Awesome. All right, so let's go to number 10. Diego wrote, oh, Diego. All right, he wrote, oh man, he did do this wrong. Okay, so 6 to the 4th times 8 to the 3rd equals 48 to the 7th. Okay, what was Diego's mistake and how do you know? All right, so here's Diego's mistake. He added these exponents, right? Which is the product rule. We only use the product rule when the bases are the same. So this is wrong, right? Because we're not getting the same base here and we don't have the same bases over here. What he did do right was he multiplied, well, when we have two different bases, we can multiply them. But that's only if the exponent is the same. The exponents are different. So what happens here is you end up with, okay, 6 times 8 times 6 times 8 times 6 times 8, because we've got 3 8s and actually 4 6s, so there's one more 6. So 6 times 8 does equal 48. So we've got 1, 2, 3 48s times an additional 6. That would be the correct way to simplify that if you wanted to just have a number, like a single number with an exponent. Okay, so that's what he did wrong. He used the product rule when he had two different bases. It kind of messes people up. All right, let's go on to number 11. Okay, so select all the true statements. Okay, so we're going to go over A and D first because we've got the same thing on one side of the equation, so we can very easily tell which one's true and false. All right, so here, what we want to do is, oh look, the bases are the same. So we can just use that product rule and add the exponents. Well, 8 plus 9 does equal 17, but this base is 4, not 2. So this one is false. Down here, 2 to the 17th power, that's correct. So that is true. All right, let's go on to the next one. So we've got 8 squared times 9 squared equals 72 to the 4th. Okay, so we've got the same exponent here. Great, which means we should have the same exponent here. Oh, but we don't. Okay, so that's a red flag. That one tells us it's not true. Let's keep going with this. All right, so we know this is false, but if we had 8 times 9, and we have both of them show up twice, so we have 2 8 times 9s. Well, we have 2 8s and 2 9s. So 8 times 9 does equal 72, which means we'd have 2 72s, or 72 squared. So this one, C, is true. All right, so the pattern here, we've got false, false, true, true. If you got those correct for number 11, good work. All right, folks, thanks for listening in. If you have any questions, I encourage you to go back through the video and see if I answer them at any point in it. If you have a question about number 9, just go back to the part where I go over question number 9 and see if there's anything that you missed out on my explanation. If not, you can join me in my office hours to ask any questions. My office hours are posted on my Canvas homepage, so please check there. Have a wonderful rest of your day and good luck on the Unit 7 test.